Ma'am, are you showing the orbital velocity slide? Because I think it's
Orbital
lagging.
velocity I touched. I completed orbital. Now escape was
No, ma'am, you didn't
while
complete
solving
orbital yet.
We stopped at finding the general form of acceleration due to gravity. Yeah.
Okay, fine. So the general formula for acceleration due to gravity, this is acceleration due to gravity on the surface. What happened? Acceleration due to gravity at the surface of the earth, at the surface. So acceleration due to gravity G is equal to Gm divided by r squared. If the object was lying on the surface of the earth. Now, where is your satellite lying? The satellite is lying at a distance of small r from the center of the earth. Now, boys, the expression what I have written, Gm divided by r squared, is the acceleration due to gravity when a body is lying on the surface of the earth, right? G is equal to Gm by r squared is acceleration due to gravity when the body is lying on the surface of the earth. What happens when the body is at a height h above the ground? That is, your satellite is at a height h above the ground. Then the acceleration due to gravity of, on the satellite will be Gm divided by what is the distance between the satellite and the earth? It is r squared. Correct, boys? What is GH? Acceleration due to gravity of the satellite. Acceleration due to gravity of the satellite. Acceleration due to gravity of the satellite is GH. So from here, you take the value of Gm and substitute for Vc. Get me the value of Vc.
Ma'am, the last thing, ma'am, we have to write after this r is equal to r plus h.
Yeah, yes, boys. This is 1 second. What you have to write is this one, boys. Acceleration due to gravity of the satellite. That is GH. Because the satellite is at a distance of r plus h from the center of the earth. So you get a value of Gm. This value of Gm you have to substitute in the expression of Vc and get me the value of Vc.
Ma'am, so should we write the expression for acceleration due to gravity on the surface of the earth?
Boys, find the value of Vc.
Ma'am, what is the, could you show equation 1?
Okay, what was Vc, boys? Was it Gm divided by r plus h? Just check others, those who have completed. Can you find?
Yes, ma'am.
Yes,
I got
ma'am.
value
Okay, now you
VC.
substitute, boys. What happens?
Ma'am, VC is equal to root GH into R plus H.
Okay, the whole square divided by r plus h.
Yes, ma'am. Yeah.
So what will you get, boys?
Ma'am.
GH into r plus h. So Vc becomes equal to root of GH into r plus h. This is the velocity velocity of the satellite at a height h above the ground. Now we'll go for the special case. If the satellite is near the surface of the Earth, if the satellite is near the surface of the Earth, what happens to the value of h? 0. So Vc becomes equal to root of g h into r. Acceleration due to gravity at a given height into r.
So Vc will be equal to root of gr.
Gr. We can write it as gr. Now before I'll go for what is that? Escape velocity. I think I'll make it to solve a numerical. Then we'll move on.
Ma'am, in this derivation, should we write the value for g near the surface of the Earth, like you told that at one point?
No need, boys. Just that's for your reference. I have to.
Okay, ma'am.
Gh is the value of the acceleration due to gravity at a height h above the surface of the Earth.
All right, ma'am. Thank you.
Completed, boys. Once you complete, you just tell me. One 1.5 volt. 1.5 volt. Boys, have you completed? Why are you writing? And Sunil, why are you writing? Hello, boys. Are you writing?
Yes, ma'am.
What's happening? Someone is. You boys. 11B.
Vishesh, your mic.
Vishesh.
Vishesh, is it physics class or something parallel class?
Ma'am, I'm close friends with him. He has two, like one cousin and one his own
Vishesh,
sister.
whose microphone is that? Is there any parallel class going on?
Hello?
Voice.
Ma'am, am I audible?
No, I think so.
Chantal's family and friends smuggled in over 20
I
Voice,
think you can mute
someone
it.
is
I think you
ask
can.
them to mute. Otherwise, I have to mute.
Ma'am, I think you should mute, ma'am.
Mute his TV, ma'am.
Ma'am, I don't think he can hear.
Vishesh has switched on and went, I think so. Wait 1 second. No, I'll not be able to hear. Okay, I'll go for the next numerical. Boys, I'll just go for this. Boys, just read the question. Now try to do by yourself. Let me see how far you people will be able to do this. A rocket is fired from the Earth towards the sun At what point on its path is the gravitational force on the rocket zero? You understand the question? 1 second. Suppose this is the sun. So the earth is moving around the sun. Okay. At least this much I'll just go for it. So you have a rocket. So you put the rocket, a rocket is fired from the earth towards the sun. Okay. So somewhere here you have your rocket. Fine, boys. So let the mass of the earth be me, mass of the sun is ms, mass of the rocket is m. Now the question is, see, the rocket will experience a force due to the sun as well as the force due to the earth using Newton's universal law of gravitation, because there will be a force between m and me, there will be a force between m and ms. Now the question is, at what point, say at point P, the gravitational force experienced by the rocket due to earth and the sun should be equal to 0. Mass of the earth, mass of the sun is given, orbital radius is 1.5, 10 to the power of 11 meters. Think how you people will do this.
So ma'am, it will be like we have to add gravitational force from sun and earth. It will be equal to total.
Total will be, what is total?
0.
That's correct. 0. Yeah. Do that, boys. Do that. You just proceed. Whichever way you want to proceed, proceed, but get me the answer. What should be the distance? Suppose if I go for this distance is x. From the rocket to the earth is x. Then you have to find what will be from the point P to sun. If the orbital radius, is r. Orbital radius means what? The distance between the sun and the earth is r. (500 ohms).
Ma'am, in the diagram, what is ms? Is it the sun?
Mass of the sun. Mass of the sun. Me is the mass of the earth.
Ma'am?
How many resistance? 1 second, boys. How many resistance box lab is having?
I have to go somewhere. Ma'am,
Okay,
is it
fine.
okay if I leave the class early?
Fine.
Thank you.
Okay, fine. Resistance box 500 ohms. Galvanometer we need. So already 4 we have. We need. So already galvanometer we have 4. Suppose if the students are 50, generally students will be 16. So 16 means we need 12. Right? I'll go for 12. Battery we have. Battery it is 1.5 volt battery. 12 we have. How much? Holders we have 6. So if same thing as per the resistance box, 16 students in one batch physics. I'll write 11 or I'll write 12. 72. Okay. Button cell. So how much I will put? 10. Okay. All button cell all type. Fine. Thank you. I have to say. I see. Meter bridge we need 5, right? Fine. Potentiometer is working. Boys, what is the fine? Boys, how will you do this numerical? How will you proceed? 11B, right? Kavin, Jayant, sorry, Jayant is not in this. Kavin, B.
Yes, ma'am.
How will you do? So the gravitational
We
force.
equate it to 0, right?
Right. So what is a gravitational force between the rocket and the sun, boys? What is the gravitational force between the rocket and the sun?
69.
What is okay, fine. So what will be the force between the rocket and the sun? G, mass of the rocket is m, mass of the sun is s, divided by what is the distance between them? Because the distance between Earth and the sun is r, the distance between the rocket and the Earth we have taken it as x, so that the distance between sun and the rocket will be r minus x the whole square.
Yes, ma'am. Yes.
Okay, that must be equal to g m mass of, this is the force between the rocket and the Earth. Sorry, x square. What are the terms which will cancel out, boys? So now you will get me by x squared must be equal to ms by r minus x the whole square. So I can cross multiply r minus x the whole square by x squared must be equal to ms by me. Is that correct, boys? So let me take square root on both sides. R minus x by x must be equal to square root of ms by me. Now from this expression, right, boys, you have to find the value of x. X is the distance of the rocket from the Earth, so where it will experience zero gravitational force. Will you be able to do this? Just substitute the mass of the sun, mass of the Earth. Then I want you to find the value of R. Vishesh.
Orbital radius is the distance from Earth to Sun, right?
R is the distance between the Earth and the Sun. That is orbital radius.
Understood, ma'am. Okay, thank you.
Vishesh.
Yes, ma'am.
You are there. Samuel. 31. Where are the other 3 boys? Okay, 1 student left.
Ma'am, Muzammil left.
Okay, fine. Samuel. Boys, what is the value?
69.
Ma'am, how is r minus x is equal to 577.3x?
Yeah, 577.
Ma'am, but how did you get that 577.3x?
It was let me do. So r minus x by, right, that is root of 2 into 10 to the power of 30 divided by 6 into 10 to the power of 24. So this becomes root of, I can write 1 by 3, 10 to the power of 6, correct? So let 10 to the power of 3 square root of 1 by 3. So how will I be able to do this? Square root of 1 by 3, what is square root of 1 by 3 was?
It's 0.57. It's 0.57.
Nice.